just like we have the laws of exponents, we also have laws governing the rules of logarithms here, and these are the three that we're going to be focusing on in this section. M and N have to be positive real numbers. In other words, you cannot have a negative argument. We've already seen that that doesn't work. P is any real number, so P is the power here. Then we have the following rules. If I want to expand a logarithm, that's what I'm doing here. I'm starting with 1 and I'm ending up with more logarithms. I can expand it if there's multiplication inside or inside the argument by making it addition between two logarithms. If there's division inside a logarithm, inside the argument, then there's going to be a subtraction symbol. That kind of looks like a little subtraction symbol there, between two logarithms. Notice whatever's in the numerator is going to be positive in front of its logarithm. Whatever's in the denominator is going to be a negative in front of its logarithm. And then the last one is the power rule. You can pull a power down in front of a logarithm and make it into P times log base A of M. So with those three properties, we're going to take a look at these following questions and expand them, leaving no exponents in our final answer. Notice here I've got two different variables in the problem, so I'm going to expect to see two logarithms when I expand this. I also see a division bar, which means there's going to be subtraction in my answer. On top, x to the 7th, so it's going to be a positive in front of its logarithm. And because the y squared is in the denominator, there's going to be a minus in front of its logarithm. To finish this out, we're going to pull the powers down in front. And then that's our expanded form. We can't simplify any further. When we talk about simplifying, we're looking to see if you have a number in your argument, you might be able to simplify that logarithm down further. If there's a variable, you're not going to be able to. In the next question, notice there's no division bar in this problem like I had here. The division bar meant subtraction. No division, so all of these are going to have pluses in front of their logarithms, or they're all going to be positive. Notice here I've got two variables and a number. So 1, 2, 3, I'm going to have three logarithms that all have positives in front of them. So my first one, log base 10 of 100 plus log base 10 of x to the 9th plus log base 10 of y. The last term here doesn't have a power, so there's nothing to pull down. That's as simplified as it's going to get. This one, the middle term here, does have a power. The 9 is going to go down in front. The first one doesn't have a power. I mean, it's got 1, but you can't, it doesn't really do anything to pull a 1 down in front. But it is a number. So let's think about this. This is log base 10, notice it'd be a little 10 squeezed in there, of 100. We can simplify this and think about 10 to what power gives me back 100, and that number would be 2. So this would be 2 plus 9 log base 10 of x plus log base 10 of y. Remember, we don't have to write the little 10 in there, but it's okay if you do. If you're not sure about this simplifying part, you can use your calculator. And since it is base 10, I can just simply type in log and then 100. And I get the 2. Okay. For this next one, count up the number of variables and constants that are in there, or numbers. So I've got 1, 2, 3, 4. So I'm expecting 4 logarithms, 2 of them to be positive, 2 of them to be negative in front of their logs. So my first one, log base 3. Again, notice I make the 3 down below the letter G of 9. So I know what the argument is and what the base is. If you put the 3 too close to the G on the same line, it's hard to tell what your base is. Plus log base 3 of x to the 4th. All right, the next two are down below the line, so they're both going to have minuses in front of them. Log base 3 of, now the square root of y is nice, but I want a power. And remember, the square root can be rewritten as a fractional exponent. We talked about that earlier, y to the 1/2. And that way I can pull the fractional exponent down. I can't pull a radical in front of the logarithm. That looks just weird. And then minus log base 3 of z to the 5th. From here, pull your powers down and then simplify any logarithm that has just a number in it. So again, we're here with this log base 3 of 9. 3 to what power gives you back 9? You can either come up with a number, in this case 2, or you could use your calculator and do change of base and figure it out that way, doing the natural log of 9 over the natural log of 3, and then computing it out. Pull the powers down in front. When they do come down in front, that's multiplication that it's hooked by here. So it's 1/2 times log base 3 of y and minus 5 times log base 3 of z. So for the next one, I've got 1, 2, 3 logarithms in my expanded version, and I'm going to see 1 positive and 2 negatives. So natural log of x, I don't want that radical on there, so that again is a square root, fractional exponent 1/2, minus natural log of 2 minus natural log of e to the 5th. Power comes down. 2 is a number, so I'm going to see if it comes up a nice round whole number, we're all good to go, and I can simplify it. If not, I'm not simplifying. I'm not writing on a decimal, so I'm not going to write that in. I'm just going to leave it as natural log of 2. Now, this guy here is a property that we talked about early on with logarithms. Natural log of e to the x, we said was just x. So natural log of e to the 5th is just 5. If you've forgotten that property, again, you could check it out with your calculator. Natural log of e to the 5th, I just got to watch my parentheses here, comes up 5. Right. So for this last one, count up 1, 2, 3 positives and 1 negative. So log base 4 of 64, that's a number one that I'm going to have to check, plus log base 4 of a to the, let's not write it as a radical, but a fraction, 1/3 this time because it's a cube root, plus, and again, don't forget to put the base in, log base 4 of b to the 12th, otherwise I'm going to think it's log base 10, totally different thing, minus, because we're down below the line, log base 4 of c. All right, so log base 4 of 64. We're looking for a power on 4 that'll give me back to 64. You could, again, do the change of base and use your calculator. Natural log of 64 divided by natural log of 4. Close out your parentheses. That should come up the number 3. And then pull your powers down. And that's it. So what you're going to see next is taking something that's expanded and then condensing it back to one single logarithm. But knowing the negative means it's down below and the positive means it's up above, and these numbers in front are just powers, you can kind of work your way backwards and put it back together again.